Okay students, now we will move on to the unit 2 where we are going to talk about parametric tests. Remember in unit 1 we spoke about how to do the data entry, the features of SPSS and all other details. So in this unit we are exclusively going to talk about how to work out the parametric statistics. Remember parametric statistics, where when using parametric statistics you have to be very careful. Before you subject your data into analysis, please check for normality, check for the data using Shapiro-Wilk test. So once in Shapiro-Wilk test, the significance value, if it is more than 0.05, that means the data follows normality. Once you have that, now you can check, you can do several parametric tests. For example, t-test, f-test, correlations, regressions and so on. Within our time limit we will do one by one. Now we start with the t-test. Now we will see how to work out an independent samples t-test. This test was earlier called as student t-test as well as unpaired t-test, but the latest nomenclature is independent samples t-test. Now you see on the first column I have defined gender and memory ability. The gender I have classified into male and female, and memory ability as scores. Now remember, t-test we do when we compare two groups randomly drawn from the population. So I have drawn 10 males and 10 females from a general population, and I have given a memory ability test. Now how to go about finding out a mean difference among male and female and then get to know whether this difference is significant or not. So to do this, what I do is I go to menu, choose analyze, I will go to compare means and select independent samples t-test. Now we can find on the left side a large box and followed by on the right side few boxes. The first on the left side box indicate what are the variables we have entered in the file, and on the right side we have to choose. So my test variable is memory ability, my grouping variable is gender, so I am bringing into their respective boxes. Then you can still see our OK signal is not highlighted. So in such cases it is still asking define your groups. So I define, remember gender 1 as male and gender 2 as female I have previously defined, and now my OK signal is ready. I can go to additional options like what percent I have to confidence limit I have to fix and all. That is not very important right now, but all other things are ready. What I do is just click OK. Now you see how the data, the analysis has come now. Now we can see male with the n of 10, mean of 17.7 with the SD of 3.33, whereas female with the 10, n 22.10 and 3.17. These are descriptive statistics. Now whether males and females they differ in their memory ability, I have to look for a t value and I have to look for a significance value. Look at the t value now, that is minus 3.02. Don't worry if it's minus. Why? Because if the second mean is bigger than the first mean, automatically you are going to get a minus value. It is just the directionality. But my prime importance is on significance, 0.007. Remember last time only we spoke, any significance value which is 0.05 and below is to be considered as significant. That means what now? Now you see a mean difference of 4.40, mean difference between male and female is significant. Why? You can find mean difference is 4.40 and the significance is 0.007 with the degrees of freedom of 18. Now it definitely says that the mean difference between males and females is significant. In other words, what you can say is females have scored significantly more than males. This is how in simple you can interpret a independent t-test. We will move on to the second type of t-test referred as paired samples t-test. Remember in paired samples t-test the data will be collected before and after on the same subject. This is more important. Also sometimes called before and after design or pre and post, whatever it may be. The idea is you are going to check is there any change from one session to the next one. I have already entered the data on some specific issue, it is before drug and after drug. Now I want to see before drug the values were like this and after drug the values were like this. I want to see in between some intervention is being done, whether that intervention has reduced the value. So to do that, the data is already entered. So how to go to a paired samples t-test? So to do that, I choose analyze from the menu, go to compare means and I choose paired samples t-test. And you can see now the dialog box are different. So it asks which is your pairs of variable. So I take the first one as before drug and the second one as after drug. That's all I have to do because our OK signal is ready. So I just click OK. Now you see how the values have come. So before drug you had a mean value of 162.60 and after drug the values have been decreased to 124. But my interest is whether the decrease from 162 to 124, the decrease of 38.60 is significant or not. Now I continue further, you see significance two-tailed. So now it says 0.061. So by our rules 0.061 is non-significant. Why? Because we require a minimum significance of 0.05. So there is no difference in the scores, though there is a decrease of 38 scores, statistically it makes no difference. So we find a change of 38.60, but that decrease of 38.60 is definitely not significant. You can ask me why there is a decrease of 38.60, but why still is not significant. Now my dear students, go to standard deviation column. You see the standard deviation 70 and 43. When you have got wide individual variations and even though then mean difference is high, still you are bound to get a non-significant difference between pre to post or before or after. Now we will move on to ANOVA or simply one-way ANOVA, where you can find the comparison of more than two groups. So I have selected three groups: shock intensity with the low, medium and high and corresponding value for the time. So with such kind of data arrangement, how I do a simple one-way ANOVA? So to do a simple one-way ANOVA, I go to analyze, okay, click compare means and I go down to click one-way ANOVA. So I select my dependent list as time because time is a dependent variable and shock intensity is an independent variable varied at 3 levels. And I go to options because I need to know the mean and other descriptive statistics. And I continue with that and I want to know even a post hoc test which of the individual groups differ from other using a Sheffield's post hoc test. I continue with that. Now all my columns are filled. Optionally I can go for plots. I can generate plots using another option called as means plot. I click that and I continue with this. So now OK signal is highlighted. So I just click OK. Now you can see how ANOVA table has been emerged, the descriptives have been emerged as well as the graphics. So now you see the time scores for low is 17.16, medium 22.16 and high 42.16 with the respective standard deviation and other descriptive statistics. But more important is whether there is a significant difference between these three groups. So I go to F value, I find the F value as 40.127 with the significance level of 0.000. That means what? The significance of 0.000 is very highly significant. That means what? Now there exist definite mean differences between these three groups. And how to confirm this? I go for further a Sheffield's post hoc test. This is where whenever the F value is significant, you have to go for a multiple comparison test. Usually I prefer a Sheffield's post hoc test. So once I go to Sheffield's post hoc test, you can find that in subset 1, both mean scores of low and medium groups are in the same subset. That means what? There is no difference between these two groups in their mean scores. In other words, you can find the mean score of high intensity group coming on the right side with the subset of 2. So our interpretation could be the entire significance has come from the high intensity group which has contributed maximum for the difference. Further, it is very clear by you can see with the means plot where you can find low and medium on the lower side and a sharp increase in the high intensity group in their time scores. This is how simple you can explain one-way ANOVA. So far we have seen difference based tests. Now we will slowly move on to relationship based tests. For example, I want to correlate reading ability and GPA scores. Now how to do about this? Remember, the score should come in pairs because it is a subject 1, subject 2, subject 3. Likewise, I have taken the scores of 15 subjects and I have entered their data. Both are dependent variables, no independent variable. So there is no question of defining the values here if you see here. So they are the direct scores. So to generate a correlation coefficient using SPSS, I follow this. I go to analyze, I select correlate option and further I select a bivariate option. Now it asks which of the variables you expect to get a correlation. So I select both reading as well as GPA. By default, Pearson correlation is identified. Optional you can go for Kendall-Stau, or if you are going for a non-parametric test, you can go for a Spearman correlation. But my interest is on the Pearson correlation. I want to flag the significance ones. So I click now, everything is done. I click now OK. Now you can see a correlation coefficient of 0.867. Remember, SPSS generates a matrix. So you can find this way as well as this way. A correlation coefficient of 0.867 is found to be highly significant. Dear students, don't forget to see the directionality of the correlation. If there is no minus sign, that means it is plus or positive. That means what? We find a positive relationship between reading and GPA scores. In simple, as the reading ability increases, GPA scores also increases and vice versa. Don't worry, what is this 0.000? It is nothing but the significance level is at the very high level, so that you can definitely say now there is a significant as well as positive relationship between reading and GPA scores. Now how, if there are 3 groups, what to do then? So we have to go for simply one-way ANOVA. One-way ANOVA compares the mean differences between the groups of values when there are more than 2 groups. So for example, suppose you are having 3 groups, ANOVA will be handy for you. How ANOVA will be done? Now I have a data for that. Okay, we continue with the ANOVA. This is how it is being done. Students, in this unit we have seen how different tests are done. For example, we have seen how independent samples t-test is done, how paired samples t-test is done, how ANOVA is done, and even we tested how a correlation can be performed. All this will be very handy for you in your dissertation or in your PhD work. So hope you enjoy this unit. Thank you.